So, we're talking still about probability. Today we're going to be talking about theoretical probability and experimental, okay? So a theory is kind of like what we think will happen, okay? So theoretical probability is going to be what we think will happen from the information given. Experimental is going to be they actually tested this. These are the results. Now find the probability. So do y'all see the difference in that? Okay. So the first type we're going to talk about is theoretical probability. What you need to know for this, just a few terms. You don't have to necessarily write these down as long as you know them. Probability is how likely an event occurs. The result is just the outcome of what we got. Sample space is the possible outcomes that could happen. And then an event is an outcome or a set of outcomes. Okay? Now, what you do want to write down is how we find theoretical probability. And that is the number of favorable outcomes divided by the total number of outcomes possible. So, favorable. That would be like me saying, what's the probability of choosing a blue M&M out of a bag of M&Ms? So the favorable outcome is that you do choose a blue M&M. Okay? Depending on how many blue M&Ms there are, that's what number would go on top. Okay? And so I will show you an example of this. Remember that I am posting this on Schoology, so if I move ahead and you're not ready, you can copy it later. Okay, so here's an example of this. There are 6 green dodgeballs, 3 red, 5 blue. I want to know what is the probability that you will randomly select a ball that is blue, okay? So my favorable outcome is that it is blue. How many opportunities do I have to pick a blue? 5, because there's 5 blue dodgeballs. So I put the number of blue dodgeballs over how many can I pick from? 14 over the total. So 5 out of 14, that's my chances, and if I divide it, I get 35.7% chance that I would pick a blue dodgeball. Yes. Okay. Are there any questions on what we just did right there? Okay. I'm pretty sure I'm going to have you try one next. Okay? So this is what you're going to do on your piece of paper. If each letter of the word probable is written on a separate card, the cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? Okay, a consonant is a letter other than a vowel. So look in this word, figure out how many consonants we have, not out loud, but on your paper. Write down what you think the answer would be. Do you have a question or you have the answer? Okay, hold on one second.
Is that correct?
No.
No?
Mm-hmm.
Hello.
Okay. I don't think some of us know what consonants are and what some of us know. Hey, shh. What consonants and what vowels are. Okay. So the number of consonants we have P, R, B, B, L. It's anything that's not a vowel. So there's 2, 3, 4, 5. 5 consonants out of the whole, all of them that we have to choose from, which is 8. Okay? 5 out of 8 is 62.5%. Okay, how do we feel? Okay?
Gotta read the question.
Now, I want to talk to you about the complement of something, okay? The complement is always going to be 1 minus what we actually want to happen, okay? So whatever event we want. So let's say I had a dice, and I wanted to know what is the probability that you don't roll a 2. How many sides does a dice have? 6. How many sides has 2 on it?
1.
Okay, so 1 out of 6 would be me rolling a 2. The complement would be 1 minus what I want to happen, okay? And that would be 5 over 6, or 83%. The other class said, well, can't you just think of it as there's 6 sides? There's a 2. We don't want to roll a 2, so that leaves us with 5 out of 6 outcomes. Yes, you can think of it that way as well. But you will see the word complement on things like the ACT and other things, so I want to make sure that you know what the complement means. Okay? And you can think of complement as, if I want someone who complements me, whatever my weaknesses are will be their strengths, so that together it would be whole, right? So here, this is the same thing. You have what you don't want and what you want come together to make the total possible thing. What is a whole? A whole is 1. Okay? So shouldn't what you don't want and what you want added together be a whole thing? If I have a pizza and I don't want half and I scoot it over, okay? So I want half, I don't want this half. Together it makes a whole. That's what I'm saying. Alright, on to experimental probability. This is the number of times an event occurs over the number of trials done. So this is where somebody has already tested it and it has information and we're finding probability from that information. So if a spinner was spun 100 times and the spinner landed on red 27 times, yellow 19 times, green 34 times, and blue 20 times, we want to know what is the probability you spin and land on red. Okay? So from this information given, how many times did they land on red? 27. Out of how many times did they spin it? Okay, so what percentage is that? 27%. Okay, so 27 out of 100 is 0.27 or 27%. Now, what if I ask the probability that you don't roll a yellow?
81%.
Okay, you can't just read what's on the screen.
No, I can't see.
How would we find the probability that we don't roll a yellow?
Subtract 100. No, subtract 90 from 100.
You could subtract 19 from 100. How many times did they roll yellow? 19. We don't want to roll yellow, so what do we need to get rid of? The 19 times they rolled yellow out of the 100 times that they went. So 100 minus 19 is 81. So we'd have an 81% chance that we would not land on yellow. This is very logical. If you think about it logically, it's going to be easy and simple. Do we have questions? Okay, I want you to try this one on your paper. I want you to find the probability of spinning a 4, okay? So there was 4 numbers on the spinner, 1, 2, 3, and 4. They spun or landed on 1 6 times, landed on 2 11 times, landed on 3 19 times, landed on 4 14 times. So find the probability that we land on red from that given information? I'm sorry, on 4. No. What event do we want to occur? Okay, so how many times did they spin on 4? So that is over the total number. Okay, so I didn't actually put the answer on the slides. I left it out. Okay? How many times did they spin and land on 4? 14 times. How many times did they spin it, period? 50. So the percentage of landing on 4 would have been 14 out of 50. And if you put that in your calculator, that would be 28%. Okay, are there any questions so far? Okay, the next thing that I want to talk about is independent and dependent events. Okay, the first one is independent. And so in an independent event, one event happening does not depend on the other event happening. They are strictly their own event, like tossing a coin. If I toss a coin and it lands on tails, does that landing on tails affect what happens the next time I flip that coin? No, those are independent. They don't depend on each other. It doesn't matter what I land on. There's still two outcomes that it could be. Okay? So what you need to know about this is you would have to do the event of this happening, event A, times the probability of event 2 happening. Okay? So event A times event 2. Okay. So here's an example of that. Okay? We have that. We want to find the probability of spinning a green, then spinning a red, then spinning a green again. So in a spinner, when I spin it once, does that affect my chances of spinning something else the next time? No. Those are independent. Okay? So how many green spaces are there? 2 out of how many? 2 out of 8. Okay? So my chances of spinning a green is 2 out of 8. What are my chances of spinning a red? 2 out of 8. And what's the chances of spinning a green? 2 out of 8. So the probability of doing green, then red, then green again is going to be 2 out of 8 times 2 out of 8 times 2 out of 8, which is going to get me 8 over 512, or 1 out of 64. Okay? The more things that you want to find the probability of, like this happens, and then this happens, and then this happens, and then this happens, the smaller your chances of it actually happening it's going to be. It's like saying the chances of me winning the lottery, getting a free car, and winning the Nobel Peace Prize. What are the chances of that happening? Very slim. Probably like 0.000001. Okay? So the more things that you add, the less likely the probability that it's going to happen happens. All right? So what I want you to do, I want you to find on your piece of paper what is the probability that you flip a coin and land on tails 3 times in a row. Okay? So we're doing this thing 3 times. So you're looking at the outcome you want and how many outcomes there are. Just like we did that last one. Sitting there and not solving it is not going to help you.
I think.
Good. Yes. Good. Mm-mm. Good. 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 Mm-hmm.
Can I go to the restroom?
Not till notes are done. Okay. So, this is what we should have gotten, either 1/8 or 0.125 or 12.5%. So the chances of flipping a coin and landing on tails is 1 out of 2, right? Because there's only a heads and a tails. So we do 1 out of 2 times 1 out of 2 times 1 out of 2, which would be 1/8. Okay? Now, the only time, some of you added, the only time you would add is if it said this happening or this happening. And means multiply, or means add. Okay? Because the chances of me no. The chances of me eating here or the chances of me going out to eat is greater than the chances of me eating here and going out to eat. Because that doesn't make sense, right? Like, the more things you add happening at the same time is going to be a lot bigger, or the probability is going to be a lot smaller than if it was this or this. Okay? So, what I want you to write on your paper right now, because it's not in the notes, is or means add. Okay? Because you will see that in your homework. So, or means add. And means multiply. Okay, now, dependent events. I need you to listen very carefully on dependent events. Dependent means that my second event depends on whether my first event happens. So, an example of this, whether I go to the beach is dependent on whether the sun is shining. So, my second event is dependent on my first. Because if the sun's not shining, there's no point in being at the beach. Okay? So that is an example of dependent. Okay? So we will still multiply with dependent, just like we did with independent. Y'all ready for an example? Okay, here's an example. If we're looking at cards, what is the probability that you choose a 2 and it is red? Okay? So my second, it is red, depends on my first. My first event is just that it is, that it's a 2. Okay? It says, what is the probability that you can choose a 2? Okay? So my event A is that I choose a 2. How many 2s are there in a deck of 52 cards? 4. Okay? Event B is assuming that we picked a 2. Okay? There are 4 2s in the deck. How many of those 4 2s are red? 2. So it would be 2 out of 4. So there are 4 2s out of the whole deck. 2 of the 4 are red. We would multiply those. Does that make sense? Yes or no? Okay, so if we multiplied these, my 4s right here would end up canceling. And we'd get 2 over 52 or 1 over 26. Or 3.8%.
But if you didn't cancel the 4s, would it still work?
Yes, it still ends up being exactly the same. Okay, you're going to have a problem just like this in a second, so I need to make sure you actually understand how to do this. Yes?
Are dependent or independent probabilities, which one is like lower?
Which one has the less probability of happening?
Is it dependent because it depends on the order?
Yes.
Yeah.
Okay, here's another example. Okay? We have 2 cubes. One is red, one is blue. We're rolling both of them. Okay? They want to know what is the probability that the red cube rolls a 1 and that the 2 cubes added together, their sum is less than 4. Okay? So let's look at event 1 first. What's the probability that we roll a 1 on the red cube? How many sides are on a cube? 6. Okay? There are 6 sides. So what's the probability we roll a 1? 1 out of 6. Okay? Now, if we roll a 1 and we have 6 sides, how many of those sides or numbers could we add to be less than 4? 2. Okay? We could have the red one, the blue one together make 2. We have red 1, blue 2, which makes 3, which is less than 4. And then anything higher than that is not less than 4, right? The sum's not 4. So that would be 2 out of 6 options. So the red cube is 1 out of 6. The sum is less than 4 is 2 out of 6, which reduces to 1/3. So the event, or the probability that both of those happen, would be the first event times the second event. So 1 and 1 is 1. 6 times 3 is 18. Yes. Okay. I'm going to have you do one now.
Is it going to be that complex?
Okay, I want to know what is the probability that you pick a black card from the deck and it's an ace.
How many cards are there? 12?
There are 52 cards in a deck, always.
Each color. I mean, each suit. 13.
There's 13 in each suit. There are 2 suits that are red, 2 suits that are black. Okay, remember that your second probability that it's an ace is dependent on the first thing, that it's black.
Ooh, I got the answer.
All right. You should be solving this on your own. I will explain it if people don't get it. Okay, I'm not going to come around and individually check. You can check yourself as I show you the slide. Okay, if you think logically, half the deck is black, half the deck is red. So that means there's 26 black out of the total 52. From that 26, how many aces are there?
2.
There's only 2 because there's 4 in the deck. 2 are black, 2 are red. So 2 out of the 26 are aces. We would multiply that and get 2 out of 52. Somebody in the other class said, can't you just think about a deck and know that there's only 2 aces that are black? Yes, you can. Probability is logical. And if you will think logically instead of freaking yourself out, this stuff will be easy for you. Okay?